Hi there guys, today we're going to have a look at transforming graphs, but in particular transforming cubic graphs. But we're going to bring you back to this because this is just testing your GCSE knowledge very quickly. Now, you previously at GCSE would have been asked to, told a function of x and asked to sketch what this looks like or analyse coordinates. Now, I personally do just remember what this means, but you guys have got lots to remember, so that might be quite difficult. So the good news is you don't have to, as long as you know what this graph looks like. Now the sine graphs, even though most people think they're really complicated, it's the easiest one to use to understand transforming graphs. Because you should know a normal sine graph, for what we say for one cycle, yes it is continuous, but for one cycle it normally goes from, so this is sine of x. If we use our inequality knowledge, we can say that that is one cycle, from 0 degrees to 360 degrees, from here to here, this being 90, 180, 270. Now if we introduce this graph, if we have sine x plus 90, it's no longer an x, obviously, it's x plus 90. So if we substitute that into this inequality, and we begin to solve it by subtracting 90 to all three sides, essentially, we'll have 270 and minus 90, which means for this graph it starts at minus 90 and goes to 270. So there's minus 90 and there is 270. So it's going to go up, down, like that. So it's one cycle. You can see it is moved left 90 degrees. So this means you're going to move left, and this one means you're going to move to the right. Now again, that's a skill you should be quite familiar with. For example, if you were left with this when you're solving quadratics or even cubic graphs now, you quite often just use the shortcut x to be 3. You swap the sign, and that's exactly the same as what we're going to do, but with graphs. So here we go. So here we have our first graph. So to do this, it always helps to have an idea of what x cubed looks like. So label my axes. Always do this for a sketch. Okay, it's not too bad. So there's x cubed. And now we have to do this. So we know that this actually means we're going to move 4 left. So it's not just this point, but the reason we do this one first, because if you imagine solving it, you would have 3 of these brackets, so x would be minus 4. So that is our root. But essentially every point along this graph is moving 4 places to the left. So now you've got to just try and draw your best graph like so. Now we also need to know where it crosses the y-axis, so that's where the x coordinate is 0. All the values up this y-axis, the x coordinates are 0. So if we again pop 0 in, we'd have 0 plus 4, which is 4, and it'd be 4 times 4 times 4, 4 cubed, which is 64. So although it doesn't look like it, this scale is pretty rubbish, to be honest, but that would be 64. But that's good enough for a sketch. It's telling me where the intersection points are. Let's try another one. Okay, so again, I'm going to label my axes and sketch y equals x cubed. There we go. So this means we're going to move to the right 3. So let's put that as 3. If we wanted to find the y-intercept, again, we'll be swapping the x for 0. So that's what we would have. So it would be minus 3 cubed. Minus 3 times minus 3 is 9, times another minus 3 is minus 27. So that means we can have a root value here of minus 27. Sorry, a y-intercept of minus 27. So we know it crosses here. Oh, I wanted to change colour. Hits the 3, and there you go. You're going to try and make it parallel as close as you can to this one. So why not try and pause the video. This one is harder, but why not try it and see what you come up with. And when you're ready, just hit play. So here's a sketch of x cubed. Label my axes. Now here we go. So I'm going to write this one out in full just to reiterate something. So when we were solving this, we would have just this equals to 0, but obviously it's a minus. Now I can technically ignore these ones because we would just do it 3 times, so there's just no point, we just do it once. And this is the same as minus x minus 3. So if you were to solve this, add x to both sides, x is equal to minus 3. So it does get a little bit confusing at times what to do here, but this is still, just this bit in the bracket, you still swap the sign. So it's going to be minus 3 there. Now 3 times 3 times 3, if we're multiplying these bits to get the y-intercept, that's 27, but it's a minus of those. So again, it's going to be minus 27. So immediately you should be like, well, how can I draw a graph starting in the bottom left and hitting minus 27? Have I done a mistake? And the answer is no, you haven't, because it is a negative x cubed. So I can tell you that because of this. So x times x times x is x cubed, but this tells me it's a minus x cubed because it's minus whatever that is, which means it's going to be coming out. I hope you can still see this pen. I might change this point down here. So it's going to be coming down like that. There we go, that's not bad at all. So there's the graph in green. Let's try one more. Okay, so this is round the other way, so this could be a little bit more confusing. So let's solve it. I'm not going to write it out the other 2 times because I'm just going to ignore them anyway. So if I was to solve this, I'd have x equal to 2. So let's make a sketch. X and y, x cubed, there it is. I know my root is now going to be 2. If you think about it, that's a positive, so well, this one is not as simple to remember swapping them, so it's always easier to, if in doubt, solve it like normal. Now I am going to write this out in full just for this bit. So minus x times minus x is x squared, and then x squared times minus x will be minus x cubed. If we pop a 0 in for each of these to find the y, we're going to have 2 times 2 times 2, which is 8. So we have our y-intercept of 8, which means this graph is going to be a minus x cubed graph and come through 8. Okay, that's rubbish. Let's try this again. I'm just going to bring the minus 8 down here because it just makes it a little bit easier for my drawing. Still pretty rubbish, but it's good enough. It has the intersection points. Okay, so now you're ready to go and practice some. So good luck and watch the video as many times as you need to make sure it goes in.